This is lesson 12.4, surface area of rectangular prisms. Use the cubes to build a rectangular prism with a length of 8 centimeters. Count the number of squares on the outside of the prism. The sum is the surface area. If we do that, this rectangular prism that has dimensions of 1 by 1 by 8 has a surface area of 34 square centimeters. Record the dimensions, volume, and surface area in a table. Well, in this case, if I have dimensions of 1 by 1 by 8, my volume would be 8 cubic centimeters, and my surface area again would be 34 square centimeters. Build 2 more prisms using all the cubes. For each, record the dimensions, volume, and surface area. Well, I can take my 8 cubes, and as you can see from my table here, I can build a 1 by 2 by 4 rectangular prism. And again, because it's length times width times height, my volume is 8 cubic centimeters. In this case, though, my surface area is only 28 square centimeters. And you can see what that figure looks like here. In my second example, this is the 1 by 1 by 8. This is the 1 by 2 by 4. And then my third rectangular prism that I can build is a 2 by 2 by 2, which again has the same volume as the other two because it's length times width times height, but has a smaller surface area than either one of the first two, in this case 24 square centimeters. The sum of the areas of all the surfaces or faces of a three-dimensional figure is called the surface area. The surface area S of a rectangular prism with length L, width W, and height H is the sum of each of the areas of the faces. Each of those faces has a congruent other face. So it's 2 times length times width plus 2 times length times height plus 2 times width times height to get surface area. Find the surface area of the rectangular prism. In this case, it's top, bottom, front, back, and then the two sides. And you can see they've drawn this out as a two-dimensional figure in what we call a net. So our top and bottom are 5 by 4. We have 2 of those. Our front and back are 5 by 3. We have 2 of those. Our sides are 3 by 4. We have 2 of those. So we have 40 plus 30 plus 24, our surface area of 94 square centimeters in this case. The surface area of this rectangular prism, a 9 by 7 by 13, would be 2 times 9 times 7 plus 2 times 9 times 13 plus 2 times 7 times 13 without drawing out the net. We've simply used the formula they gave us before, which is what I think I'm going to do in most of my examples. So, in example A, it says find the surface area of the rectangular prism. In example A, I'm going to do 2 times 3 times 10 plus 2 times 3 times 6 plus 2 times 10 times 6. I'm just going to throw some parentheses in there to make this a little more clear, though I don't really need them. And what I've got is 60 plus 36 plus 120, or a surface area of 216 square meters. That's 2 times length times width, 2 times length times height, and 2 times width times height. In example B, same thing. 2 times 3 times 11.2. I'm going to throw parentheses around that because it's got a decimal. Plus 2 times 11.2 times 11.2 plus 2 times 3 times 11.2, which gives me 67.2 plus 250.88 plus 67.2 for a surface area of 385 and 2800ths, in this case millimeters squared. Domingo built a toy box 60 inches long by 24 inches wide and 36 inches high. He has 1 quart of paint that covers about 87 square feet of surface. Does he have enough to paint the toy box? Well, 2 times length times width plus 2 times length times height plus 2 times width times height gives us a surface area of 8,928 square inches. The number of square inches the paint will cover, if it's 87 square feet, it's 1 foot by 1 foot, which gives us 144 square inches. So 87 square feet is equal to 87 times 144 square inches, which is 12,528 square inches, which is more than enough for Domingo to cover the toy box with paint. Example C. The largest corrugated cardboard box ever constructed measured 23 feet long, 9 feet high, and 8 feet wide. Would 950 square feet of paper be enough to cover the box? Justify your answer. Well, 2 times length times width would be 2 times 9 times 23 plus 2 times length times height would be 2 times 9 times 8 plus 2 times width times height would be 2 times 8 times 23, which gives us 414 plus 144 plus 368. When we add them all up, we get 926 square feet, which is less than 950 square feet. So 950 square feet of paper would easily cover. If 1 foot were added each dimension of the largest corrugated cardboard box ever constructed, would 950 square feet still be enough to cover? Well, we're going to change this to 2 times 10 times 24. You can see I've added 1 to both of these. I'm going to add 1 to both of these, and I'm going to add 1 to both of these. So it's 2 times 10 times 24 plus 2 times 10 times 9 plus 2 times 9 times 24, which gives me 480 instead of 414, 180 instead of 144, and 432 instead of 368. When I add them all up, I get 1,092 square feet this time, which is greater than 950 square feet. So no, we cannot cover. We could before. That additional foot added onto each dimension makes the box too big to cover with 950 square feet of paper. Find the surface area of each rectangular prism, round to the nearest tenth if necessary. Okay, example number 1. 2 times length times width, 2 times 6 times 3, plus 2 times 6 times 4, plus 2 times 3 times 4, gives us 36, plus 48, plus 24, or a surface area of 108 square feet. Example 2. 2 times 8.2 times 5.5 plus 2 times 3.4. Now I'm not paying particular attention here to which is length and width because multiplication is commutative and I can multiply in any order I want and get the same answer. I'm just making sure that I use all 3 of the dimensions, which gives me 90.2 plus 37.4 plus 55.76. When I add them all up, rounding to the nearest tenth, I get 183.4 centimeters squared because it's surface area. Megan is wrapping a gift. She places it in a box 8 inches long, 2 inches wide, and 11 inches high. Megan bought a roll of wrapping paper that is 1 foot wide by 2 feet long. Did you buy enough paper to wrap the gift? Justify your answer. Well, let's see. My surface area is 2 times 8 times 2 plus 2 times 8 times 11 plus 2 times 2 times 11, which gives me 32 plus 176 plus 44. Add them all up and I get 252 inches squared. Now my 1 foot by 2 feet, that's simply a rectangle. I need to change this to 12 inches, however, and I need to change this to 24 inches. When I multiply those together, I get 288 square inches, which is greater than 252 square inches. So can Megan cover the gift? Yes, she can. She has more than enough. The only vocab in this lesson is surface area, which is the sum of the areas of all the surfaces or faces of a three-dimensional figure. At this point, you should stop the video. Go to www.nicu.net, log in with your student number. Your password again is your student number plus your last name, and take lesson quiz 12-4. Thanks for watching.